Assalamualaikum everyone. I hope you are all fine. So today's lecture is our lecture number 26 and it will be about more into the network security aspects. In previous lecture we have discussed about some of the basics of security and cryptography. In today's lecture we will see some more concepts about security, especially how to secure a network as well. And there are different there are different approaches and techniques which are available to secure the network. So let's continue with our discussion of security. So there are concept known to be as digital signatures, in which it is a cryptographic technique, similar as to the handwritten signatures. For example, if you want to uniquely identify that this document was being signed by a user, let's say user named as Umar, then Umar will sign that document with his signature. So in that case, the signature is a unique identifier which will ensure that this document was being signed by Umar. So similar concept has been applied to digital signature as well, in which the sender will digitally sign the documents, and hence establishing that he has the owner or the creator of that document. Yes, the digital signature are verifiable and they are non-forgettable. For example, the recipient Alice can prove it to someone that Bob has no one else, including Alice, must have signed the document because of the signatures of the digital signatures that are being used by the Bob. So digital signatures are a unique identifier used to ensure that this document was being created by the owner. So it is similar to what we usually do in our daily life by signing a document. So the signing of document basically shows how that shows that the owner has signed or created that document. It is a unique identifier. So for digital signature, there is a simple digital signature message for M. Let's say the user Bob signs the message by encrypting with his private key, so and creating a signed message as well. So the Bob's message, suppose he wants to say that dear Alice and something, the message was that, and then he digitally signed this document with his private key, so using a public key encryption algorithm. So this means this document has been digitally signed or created by Bob. So Alice will say that I have received this document from Bob because of the digital signature or the private key which is being used. So Bob's message is signed with the private key. Now the Alice received this message with message and the key of Bob, which is used to sign the message. Alice then verifies the message signed by Bob by applying Bob's public key, so that will yield a message. That will yield the message to Alice, because we have seen in the previous concept that if you have signed your message with the private key and then it is decrypt with the public key, and then your answer will be a plain text. So in that case, whoever signs M must have used, or you can say in this case, if suppose an intruder or the Trudy has broke into the Bob's place and signed with his signatures, so that means the Trudy now have the digital signature of Bob's, or you can say the Trudy has the private key of Bob. So whoever signed that the document will have now the Bob's private key. So Alice or the receiver now verifies that it has been signed by Bob. So Nobles and signed the message, and Bob signed, or maybe Bob's private key, whoever is using that. So Alice can take the message and signature to code and prove that it has been signed by the Bob to send the message. So yes, digital signatures are very useful. uh, Now, in order to secure an email, because user usually communicate with each other, officially communicate with each other using an email. So in order to secure that application as well, we will see how email is being secured now, or what is the process to secure the email. Now let's see this through an example, that the Alice wants to send a confidential email to the Bob. So how that will be secured? So now Alice will generate, you can see that in this diagram as well, in order to securely transfer that email, that is the email, that is the message, or you can see the content of the email. So in order to secure that email, the Alice will sign this message or the body of the email with the symmetric private key, okay, and then encrypt the message with KS in order to further secure that, and also encrypts the KS, or you can see the symmetric key, with Bob public key. So and sends both the symmetric key and the Bob public key. This is the symmetric key. In order to further secure that, firstly the email body has been signed with a private key, or you can see the symmetric private key, and then in order to further secure that email, because that key can easily be decrypted, in order to further secure that email, she has used a public she has used the public key of Bob to secure that key as well, to secure that symmetric key which is used to encrypt this message. So there are two encryption are being done in order to secure that email. First one is the message of that email, which is being encrypted using the private key, symmetric private key, and then that symmetric private key has been secured with the encryption of Bob's public key. So these two things, the ciphertext and cipher, you can see the key, the cipher key and cipher text, both are being sent to the Bobs. So now what will Bob will do? Bob will use the private key to decrypt the Bob will receive two things: the symmetric the ciphertext and the cipher key. So Bob will use the private key of himself, because it is been encrypted with the key of the symmetric key has been encrypted using the Bob public key. So it will decrypt that symmetric the cipher key using his private key, and will get that symmetric key, and then uses the answered symmetric key or the received symmetric key to decrypt that message, and then will get the secure email. So that's how you can secure the email. Now let's see. Alice wants to provide sender authentication message integrity as well. So the Alice will further secure that using the digital signature concept. And now Alice will digitally sign the message as well, and send both the message in clear and the digital signature. So what Bob will do, Bob will compare that message and the hash key as well to content, and get the secured authentication as well. So in order to provide secrecy, sender authentication, message integrity, Alice will use three keys: her private key, Bob public key, and newly created symmetric key, so that all that message can be secured. All, you can say, in order to avoid any possible leakage, or you can say any possible decryption at any stage by the hacker, uh, Alice will use three keys to secure that message. First one, she will sign the message using digital signature and using her private key, and then send that message using the symmetric key encryption, and then encrypt that symmetric key using the public key as well. So there is no possibility to the Trudy or the intruder to get into the content of the email. So there are some more concepts to further secure the network as well, which is the optional security measures which are used in that network, which requires this very sophisticated security as well. You can see these operational security measures as well here. First one is the firewall, second one is the access control list, then stateless packet filtering, stateful packet filtering, and application gateways, IDS, and DMZs as well. So now let's see with the firewall how network can be secured using the firewall. So the concept of firewall is that it isolates the organization or internal network from the larger internet, and allows some packets to pass you or block and blocks the rest of the packets. So this is your private network or your organization network, and it is connected to the internet, that is the public internet. So in order to secure your organization network, you will create a firewall, or you can say something, a concrete wall, or a concept that will allow some type of packets to pass and will block the other packets. The rest of the packets will not be allowed to pass through the firewall. So it means your administrated or your organization network contains good guys, and your public internet are containing the untrusted or the bad guys as well, because hackers or something like that, intruders, can be located in the public internet. So the trusted guys or the trusted user are located in your internet, in your internal network, and the untrusted users are located in the internet or the public internet. So firewall basically distinguish between basically is a wall between the internal network and the public internet. So it will filter the packets, and it will allow some packets to pass and block the rest of the packets. Why we use firewall? Because to avoid denial of service attacks. You can see in the literature that the synchronization flooding are used by attackers to establish a DOS attack. So attackers establishes many bogus TCP connections. So no sources are left for real connections. So firewalls will basically block the sync messages, or you can say that if you send the sync message of TCP connection, then you can establish a connection with the server. So there are very basic thing that is used to launch the DOS attack is the sync flooding using the TCP connection. So firewall, if your internal network is applying a firewall, then firewall will block the sync messages from the external source. So that will help to prevent the DOS attacks as well. And also firewalls prevent the illegal modification or access of internal data as well, because only authorized users will be allowed to access the resources within the network. So there are set of authenticated users which are being authenticated using the authentication protocol we have seen in the previous lecture. So there are three types of firewalls. First one is the stateless packet filtering, second one is the stateful packet filtering, and last one is the application gateways. So let's see how stateless packet filtering firewalls will work. In stateless packet filtering, we will be asking a question, simple question at the gateway point, or you can say the point at which the packets are arriving from the public internet to the organization internet, or you can say the internal network. So the question is that should that packet be allowed to come in the network? So it will be determined using packet filtering. That is, first one is the stateless packet filtering, and also in the stateless packet filtering, we will also monitor the packets which are going out from our network to the public internet as well. So internal network is connected to the public internet using a router firewall, and this is the router here, which is implemented, which has the implementation of the firewall. So this is the router firewall, and all the packets will go through him and come through him as well. So the router will filter packet by packet, and then decisions to forward or drop the packet based on the source IP, the destination IP, the source port number of TCP or UDP, ICMP message type, TCP sync and acknowledgement bits. So it will filter, or you can say allow or deny the packets based on these four criteria. So let's see through an example. In example 1, suppose you have implemented a strategy that the router will block incoming and outgoing datagrams with the protocol field to be 17, with either source or destination port number to be 23. So the result will be that all the incoming and the outgoing UDP flows, because UDP flows are identified using the protocol field 17, and the telnet connections are usually implemented at the port number 23 are being blocked. So all the result of that will be the incoming and outgoing flows of all UDP, and the telnet connections are blocked. So user will not be able to communicate on UDP packets, and there will be no telnet, or you can say remote login sessions or connections are allowed. Let's see, if we block all inbound TCP segment with acknowledgement 0, the result will be that we will be preventing external client from making TCP connections with the internal client, but we will allow internal clients to connect to outside. So it means if you implemented that, that means if you block all the inbound TCP segments with acknowledgement 0, it means only your internal users will can connect to the outside, but outsider user or the external clients can never be connected using the TCP connection to the internal clients. Second type of filtering that are used in firewalls is the stateful packet filtering, or you can say access control list. Access control list is basically is a table of rules that are applied from top to bottom to incoming packets that contains the actions and conditions pairs. You can see a typical access control list here, that the action is to allow or to deny. We will be allowing that packet which have the source IP to be something like that, and destination IP outside of that, and using the protocol to be TCP with the source port number, and that you can see that something like this. So ACL are being implemented as well to allow or deny the connections. So in stateless packet filtering, we have seen that it is a heavy-handed tool, because it admits the packet which makes no sense as well. For example, if your destination port is 80, acknowledgement bits is been set, so even though there is no TCP connection established, but your packets will be admitted. So you are no packet will not be admitted, but you are using too much of the complexity, because you are admitting and you are basically applying two type of policies from admitting and outgoing packets. So in a stateful packet filtering, we will only track the status of every TCP connection, that the TCP connection setup, that is the sync bit, the tear down bit, FIN bit, and we will determine whether incoming and outgoing packet makes sense as well or no, because of the attacks type, DOS attack types, because if that sync message doesn't make sense, it means it is being implemented, it is being sent by the intruder to attack the network. But if that makes sense, because users want to communicate or to make the connection, that we will, then we will allow. So it stateful filtering will allow the user, the router firewall, to maintain or to track the status of every TCP connection as well. So, and also we will monitor the timeout inactivity connections at firewall, so no longer admit that packet as well. So usually in the stateful packet filtering, ACL is implemented something like that. We will check the connection as well, whether it's been established or not. If it is not been established, then we will cross that. Third type of firewalls that usually are used are based on application gateways. So application gateways are in application gateways, we will filter the packets on application data as well, that is based on the TCP, UDP and IP fields as well. So your packets will be filtered based on the application type as well. For example, we will allow the internal user to telnet outside or only to use the TCP service. So in that case, we will be using an application gateway that will implement that strategy to internal user to only use that particular type of application. Let's see how application gateway are being implemented for user to only to use the telnet session to outside user. First step will be to require all telnet user to telnet through the application gateway. So it means all the outbound connections, or you can say the request for the public internet connections to telnet going from internal network will be going through the application gateway. So application gateway will make the connection on behalf of the user. So second step will be for authorized users. Basically all the internal users are being authorized using the authentication protocol. So all the authorized users will make the request to application gateway, and then application gateway will set up the telnet connection to the destination host, which has been located at the public internet. So gateway will relay the data connection between the two entities, and will and the router of that application gateway will filter all and blocks all the telnet connection that are not originating from gateway. So if any user send direct request to the router filter, then the router filter will block the telnet session. So only application gateway packets will be allowed to go through the router filter. So that's how you can see the host firstly will send the request message, or you can say the telnet session request to the application gateway, and then application gateway will make the connection on behalf of that user to the outside world, and the packet will be going through the router filter, and then the connection will be made on behalf of that user. So there are some limitations of firewalls and the application gateway, because they are a concept of IP spoofing, which can let the hackers to basically spoof their IP, and we are implementing firewalls, gateways and packet filtering based on IP addresses. So the intruders can simply change their IP address to that allowed IP address. So IP spoofing will limit the functionality of firewalls and gateways. So in case of IP spoofing is implemented by any intruder, then router filter can't know that data if that data is really coming from the claimed source, or you can say the intruder, because if multiple applications need special treatment, then each will own their application gateway. So in order to launch that type of attack, the client software must know how to contact the gateway. So in that case, it will set the IP address of proxy in the web server, and then after setting that IP address in the web server, it will be sending all the packets to that application gateway, and filtering of use all or nothing policy for UDP. So we will be trading off the degree of communication with the outside world, basically the level of security. Many highly protected sites still suffer from the attacks as well, due to that IP spoofing and something other techniques are used. So firewalls and gateways have their limitation as well. In order to further secure, because IP spoofing can limit the security of the firewalls and application gateway. So in order to further secure the internal network, or you can say your local network, we will be using a detection system called to be as intrusion detection system, because packet filtering or firewall operates on TCP and IP headers only, and there is no correlation among the sessions. So intrusion detection system basically is a deep packet inspection system that will look at the packet contents as well. For example, it will check the characteristics in the packet against a database of the known virus, or you can say the attack string as well. So or you can say the extension file, if you have attached the file, if the attacker has attached something batch file, or you can say the exe file. So the intrusion detection system will let the detection system to look at the packet content as well. So what type of packet is carrying the message, whether the message or the packet is containing a script or something is scripting as well, is been done by the hacker to hack the network as well. So intrusion detection system will inspect the packet content as well, and it will examine the correlation among the multiple packets. So it will be doing the port scanning, network mapping, and the DOS attack. It will help to avoid these three type of intrusions as well: the port scanning, network mapping, and the DOS attacks as well. So intrusion detection system is usually implemented using multiple IDDs. Basically, the multiple intrusion detection systems are implemented in a network. You can see the example that we implemented different type of checking at different locations of the internal network. For example, we have implemented three IDs. First one is located at the server, which is in our internal network, and second ID is in the gateway before the firewall, and third one is at the servers which are in the demilitarized zones. We will see that demilitarized zones concept as well. So for a while understanding now, let's take this to be an autonomous system. It has something other policies are implemented in this web server autonomous system, which is we will discuss the demilitarized zones in upcoming slides as well. So there are three IDDs are being implemented in order to sensors are being implemented in order to deeply inspect the packets of packet contents to further secure the network. So there are concept of demilitarized zones in computer networking. DMZ, or you can see the demilitarized zone, is a firewall configuration, option firewall configuration, which is used for securing the local area network, and it is basically a neutral zone between the private and the public internet. It prevents the outsider from getting direct access to the server that has a private data. For example, the FTP server, web server, DNS server usually contains the private data of the users. So these three type of servers, or you can say any server which containing the private data of the users, are usually located in the DMZs. So DMZ is an optional and a more secure approach to the firewall, and it is effectively as a acts as a proxy server as well. And the DMZs has become a necessary method because there are some different types of attacks which are being launched in order to secure the network. DMZs is a multi-layered defense in-depth approach to secure our network. And DMZs are established, separated, and protected from both the internal and external networks. How DMZ will work, and in typical DMZ configuration, most computers on the LAN will run behind the firewall, and one or more computer will run outside the firewall in the DMZ. So those computers on the outside will intercept the traffic and the broker request for the rest of the LAN, and that will add extra layer of security. So in a typical DMZ configuration for a small company, a separate computer, or you can say backbone host, receives the request from user within the private network for access to websites or the web server. The DMZ host then initiate the session for the request on the public network, and however the DMZ host is not able to initiate the session back into the private network, so it can only forward the packet that all already has been requested. So it will not do the packet routing or the packet filtering. So the user in the public network outside the company can only access the DMZ host. All the other hosts are being protected. So the DMZ host may typically also have the company's web page so that they can be served to the outside world. However, the DMZ host provide access to no other company data. Cisco, which is the leading maker of the router, is one company that sells the product designed for setting up a typical DMZ. So that's all for today, and that ends our discussion of our course as well. So Allah Hafiz.